Welcome to the Meadowdale High School Auto Shop, and this is testing a faulty wiring harness. So you guys should have all finished making your wiring harnesses from the last video, and now we can go about the process of testing them. So I got here the harness that we made in our last video, and I'm going to go through and show you guys how to test it. And I do realize that the colors of the wires that I used are different than the colors of the wires that you guys used for making your wiring harness. So I made up an extra one that had the same color wires because for some of you guys, it's just really hard to get over that. But keep in mind, the wire color shouldn't matter. You should be able to test these no matter what color wire you're dealing with. So we'll test it first using the original wiring harness that I made, and then we'll switch over to one that has the same colored wires that you guys have. So to begin our test, take your ohm meter, well, your DVOM, and switch it to the ohm setting to the 200 ohm setting and turn it on. And we're just going to go through first and find out how much resistance is in each wire. Recall that when you were building these harnesses, one of the wires you did nothing to. It was just a good solid wire. One of the wires was cut in half. One of the wires, or two of the wires were twisted together, and one of the wires had high resistance. And now we're going to electrically test to find which wire had which fault. So on my paper here, I'm going to start off with my purple wire. Just put the black probe in one side of the purple wire and the red probe in the other side of the purple wire and see what we get. And it doesn't move. My meter didn't change its display at all, which means that this is the wire that I had cut in half. So this is an open circuit. There's nobody home. So I'll record down I'll write NA on the purple wire because there's nobody home there. You could also write down that 1 as long as you know that it's and honestly OL would be the correct thing to write there for that purple wire. Next, I'll test my white wire. Black probe goes into one side, red probe on the other side. Oh, and it looks like I got high resistance on this one. 80.6 ohms. I'm just going to record down the ohms reading that I get for each wire. Now we'll go on to the brown wire. I'm getting 1.2 ohms, which seems like a little bit of a high resistance measurement, but when you test the meter together, you find that there's a lot of internal resistance in this meter. So 1.2, 1.0, that's saying that there's almost no resistance in this wire at all. If you wanted to get really fancy with it, you would take and find the internal resistance of the meter and subtract that from the resistance reading that you found. I'm not going to force you guys to do that at this time. Just go ahead and record the reading that you get. So I'm going to say 1.1 for my brown wire. Next, the gray wire. And we got 1.1 again. Now the orange wire. And we got 1.1 again. Sorry for my display there. My camera shows everything in mirror image. So now I got my ohms values. So what wires have an open circuit? Well, the one with nobody home, the one that displayed the same thing that's on the meter now when it's not touching, when the probes aren't touching anything, that was the purple wire. So what has an open circuit is the purple wire. And so I'd write purple there for my open circuits. What wires have high resistance? Well, that white wire had high resistance. Way more resistance than all the other wires. So I'm going to write down that the white wire had high resistance. Now, I got to find out which ones of these wires were shorted out to one another. And the test for doing that, I'm going to just have all the wires on the one side of the board here, and we'll just run through and test each wire to each other wire. So I'll start with the gray wire, and I'll put one probe into the gray wire and one probe into the white wire. Nobody home. Now I'll go gray to brown. Nobody there. I'll go gray to purple. Nope. Now gray to orange. Nothing. So the gray wire does not have a short circuit. So I'll just move that gray wire to the side and continue testing. Now I'll test the white wire. White wire to the brown. Nope. To the orange. No. To the purple. No. So the white wire can now be moved to the side. I'll go purple wire to the brown wire. Nothing. Purple wire to the orange wire. Nothing. So nothing on the purple wire. So now there's only 2 wires left to test. Let's see. And there we find it. We have continuity between these 2 wires. So there, that is our short circuit. So which wires are shorted out? The orange to the brown. So I'd write there. So now I've filled out my continuity test paper. Let's go ahead and repeat that process, but this time on a wire harness that has the same color of wires as what you guys all had to work with. So we'll start off with the blue wire, finding the resistance on the blue one. Oh, and I just realized I need to cut down these wire ends a little bit so that the probes can reach in there. Now that I've cut down the wire ends a bit, it's be a little easier to test. So we'll start with the blue wire, and we'll see what our ohms value is for our blue wire. And we're getting nobody home on the blue wire. So this is the one that I have cut in half. So I'll write OL for the ohms value on our blue wire. Next, I'll test the green wire. And we're getting 1.1 is what I end up reading for the green wire. So I'll write 1.1 for our ohm value for the green. Next, we move over to the black wire. We're getting 1.1. Next, we'll move on to the red wire. .1 again. Now our yellow wire. And we're getting a 66.4. So we got high resistance on that yellow wire. So what wires have an open circuit? That blue wire is the one that didn't record anything. So that's our open circuit. So I'll write down blue. Which wires have high resistance? Well, that yellow wire showed a 66.4. That's very high resistance for a piece of copper wire. And are any wires shorted out? Let's find out. So let's take, we'll just start testing all of our wires. So we'll start off with our blue wire. Blue to green. Nope. Blue to red. Nope. Blue to black. Nope. And now to the yellow. Blue wire has no short circuit, so I'll just kind of move it aside there. I'll try that green wire. Go green to red, and look at that. We have continuity. So the green wire is shorted out to the red wire on this wiring harness. So I'd fill out on my test form that the green wire is shorted out to the red wire. And that's it. That is doing an electrical test to find open circuits, high resistance, and short circuits in your wiring harness.